So is it moving
Yeah,
now?
now it is moving. Now it is moving.
I like to start with the cyber forensics evolution in Indian scenario. IT Act came in India in 2000 when computer started in common usage. There comes the this forensics and life forensics. And when the network related crime started, network forensics came. And when we started using inputted devices like PDAs and pagers, device forensics came, then the mobile forensics mobile phone crime started and the mobile forensics came into existence. And now we are in the fourth industrial revolution with IoT devices, cloud systems, cyber physical systems, and AI. When these systems come into existence, cyber crimes related to this devices also started, and there comes the relevance of forensics in new areas like IoT forensics. IoT systems are diverse in nature, and these systems exist in almost all domains like healthcare, smart city, smart home, power sector, transportation sector, etc. And when we look into the IoT usage statistics, we can see that now in 2023, there are more than 14 billion devices or active devices, and this will become more than 38.6 billion devices in 2025 and more than 50 billion devices by 2025. So coming to Indian scenario, if we look, under the Ministry of Housing and Urban Affairs, the Smart City Mission has initiated more than 100 smart city projects. And under the Ministry of Power National Smart Grid Mission, there are more than 20 projects. When all this project comes, the IoT systems in public spaces get increased, and we can expect more and more cyber crimes related to IoT systems. And now the OEMs are mainly concentrating in the applications of IoT devices and systems. So there is gaps in IoT security. There are challenges and there are many attack incidents as well. There comes the importance of IoT forensics. And IoT forensics is a branch of digital forensics which deals with IoT-related cyber crimes and includes investigation of connected devices, sensors, and data stored in all possible platforms of an IoT ecosystem. When as I mentioned earlier, when all this IoT system come into existence, the cyber crimes will also rapidly growing, and our investigators has to be equipped with good procedures and approved procedures and tools for investigating such crimes. As I mentioned earlier, the IoT systems are diverse in nature. So a system-wise specific approach, forensic approach is what we can do. And in this research, we have selected VTS, that is Vehicle Tracking System, which is an IoT system under transportation domain for conducting the research, or selected as a case study in this research. Vehicle tracking systems. These systems are devices for tracking and monitoring heavy vehicles like trucks, trailers, buses, etc. for fleet management and like this real-time status monitoring, etc. And there's an ecosystem, and it is having various platforms. Like in an IoT ecosystem, VTS ecosystem, there are VTD or vehicle tracking device hardware, which will be placed inside these heavy vehicles. And these devices will collect these vehicle parameters and will be sending to a central server. There will be databases for storing the data sent by the VTD. VTD mostly will send packets with information like location information, date, time, speed, and other parameters, engine parameters, and out of order events, etc. as packets. And these packets will be sent to a central server, and at the central server, this will be stored in huge databases. And users or end users of this application can monitor this data base using web-based applications from either from control rooms or through user end devices like mobile phones, laptops, etc. So as I mentioned, the first part of this vehicle tracking system ecosystem is vehicle tracking device, hardware device, which is what we keep in heavy vehicles like trucks, trailers, buses, etc. This is an embedded system device, and it is having a hardware board with a microcontroller as central unit. And this microcontroller have the firmware in its flash memory. And this controller will control all the peripherals, collects all the data from the sensors and other hardware peripherals and process it and create the packets and will send it to the central server through the GSM module. And the recent packets or last sent packets will be stored in the external flash memory of this hardware board. Mostly it will be chips like WinBond for storing the packets. GSM module will send this packet to the central server, mostly using SIM cards, and nowadays it will be eSIM. And GPS module of this hardware board will be getting the exact location of these vehicles, and power module will be giving power to other major units of this hardware board. So this is the overall architecture of VTD, hardware architecture of the VTD. And here forensically what is important is the packets which is stored in the external flash memory of this hardware board. And there are 47 OEMs in India, which is published by the MOTH, and ARA have listed 27 manufacturers and ICAT has listed 40 manufacturers. So there are almost 47 OEMs in India who are developing these vehicle tracking devices. And this slide shows the system we have taken for case study. That is, we have selected the VTD TZ1 hardware device as a hardware device for this case study. And the VTS application which we have selected is Suraksha MITR, which is actually a vehicle tracking system developed by CDAC Trivandrum. And the forensic artifacts in VTS is VTS ecosystem. The forensically relevant data is stored one in VTD. That is, as I mentioned, the packet inside the external flash memory. And here it's a WinBond chip with SPI interface. And this chip is having stored packets in it, and it's having 188 byte packet length, and more than 10,000 packets will be stored in this external flash memory. The details includes this latitude, longitude, date, time, then vehicle mode, altitude, and say signal. Everything is there in this packet. All forensically relevant data is there in this packet. And at the server side, as I mentioned earlier, the server side is data packets are stored in the database. As there are thousands of vehicles communicating with the central server, this database is huge, more than terabytes of data. And how it is stored is every 3 months, or it will be saving the data of 3 months data, and after that it will be in a compressed form, and after a few months it will be deleted. So if a vehicle related incident happens, we have to forensically extract the relevant portion of the database for further analysis. Otherwise it will be lost, because as the investigation prolongs for months and years, then what happens is we will lose this data related to a particular incident happened with the vehicle. So in the VTS data extraction techniques, in the VTD side, we have to extract the data from this this external flash memory. And for that, first there are some procedures to follow. First is we need to get the target vehicle tracking device. After that, the hardware analysis has to be done to identify the open ports, then ICs of that vehicle tracking device, then the protocol or the interface of that chips which stores the packets. Then we need to identify the debug ports. After identifying these ports, we have to interface this device to the host PC where the data extraction software runs. And then here we have connected our device using bus pirate hardware to our host PC where the data extraction software runs. And after extracting this hex dump from this hex dump from this flash memory, we have to analyze it for getting the relevant data. And here, after we have connected this device to host PC with Ubuntu.
Hello, Miss Amala, can you please make it fast?
Yeah, okay. So we have extracted this software we have used here is open source software, that is Flash ROM, and we have extracted the data. And at the end, we are getting a vtu.bin file with all the packets. And from the server side, what we have done is from the huge database, we have extracted, we have carved the big database using based on the date and time, and we have created the hash value of that thing and store. And as part of this project, we have also developed the IT forensic suite prototype model, which is having a software as well as hardware side. The hardware is for boards and cables for interconnecting host devices to PC, and the software is a Linux-based software which includes data extractor and analyzer modules. It is having other features like case data entering fee facilities and supports multiple domain. This is the IT forensic suite. This is a main screen where we can see